News from the battery, at least from one of them. Well, the news about this one is, or the basic news is that it has turned out in the last days that apparently sulfated batteries can be revived by applying 230 volts AC to them. I noticed a decrease in internal resistance and they started taking on charge again. Now here I've got one which has got 800 CCA and 110 ampere hours, which is not in a good condition. So this one we're going to test right now. So let's connect the battery test, and we're going to do a battery test now first. That is before it's charging, so we see that the voltage is no good, 10.82 volts. So it will complain. Yeah, battery too low or power too low. It will complain. Well, we're going to have a pre-charge test here before charging. So see what it says. Testing. Now there we go. So 0% charge. Still 11% healthy. Not bad for that. But the internal resistance is interesting because that's 11.4 milliohms. So that should go down to something like 5 or less. So we're going to have a look at that. Now, next step is to connect our AC supply. This one here, it looks a little bit improvised. And in fact it is, because it's just a test. So it's not something that is a ready-made device. So, and we're going to have a multimeter with it, which gives us the 10.9 volts right now. And connected to these two terminals is not just the mains power, but it goes through a 40-watt bulb. So we don't have a short circuit. If anything happens, it will just power the bulb and not cause a short circuit. There's a little loop here which can take a diode, and depending on which way around, you can actually define which way is the positive and the negative. So it will get a pulsed half wave of the AC that's coming in, which is essentially a pulsed DC to the battery, with which you can actually charge it. But that's not the stage. So we want AC on it. It will not pump anything into the battery, but it will just oscillate back and forth, hoping that the desulfitation, well, all these sulfur crystals will be dissolved. Now let's just plug it in. Nah. There we go. Lights on. Now what do you think about the voltage? Has it gone up? Let's have a look. 10.9. No, it hasn't. Why has it not? Because, well, it's actually not charging the battery. It's just oscillating back and forth. It's AC. So my theory is it wouldn't do anything to the voltage. It would be different, and it was different when I put the diode in. And it starts charging, but I'll do the charging with a battery charger. So what we'll do is leave it running for a while, a few hours, and normally I leave it for a bit longer, but just for the test purposes here, a few hours, leave it on there, and then I will connect the battery charger, and then we're going to test it. It won't be fully charged at the end because I would have to leave it for longer, and there's no time for that right now. But so I'll leave you with the shine of the bulb, and we shall see what happens with the battery afterwards. If there is any improvements, that's the interesting bit we want to see. Oh, a bit more about the battery now. So the battery is still connected to the mains voltage, 230 volts, and the light is still on. I covered it a bit because it would blind the camera otherwise. So let's have a look if the voltage has actually increased here. So it's all still connected as it was. And what have we got? 10.9 volts. So nothing has increased. It's been connected for a few hours now, and we shall now change over to the battery charger and start charging, and we'll catch up in a next little session. Once we've actually charged the battery a little bit, we won't be able to charge it completely, but let's see what happens.